Hello, you are watching part 2 of the MLX Programming Guidelines and Common Mistakes tutorial. In this tutorial, we will discuss state management of the MLX system and common mistakes with restarting or redirecting motions. First, we will discuss managing MLX states from application logic. The state of the system can be controlled from the MLX HMI main screen. However, it is often useful to do this from application code instead. For example, these code commands could be used to automatically start a system upon power-up or to automatically stop the system based on some sensor inputs. This picture shows the states of the system. When the system is first initialized, it is in the servos off ready state. This implies that there are no errors in the system and that the servos are not yet enabled. From there, the MLX enable command will bring the system to idle. In idle, executing any motion will move the system to running, and the MLX stop command can be used to cancel any currently queued motions and move the system back to idle. While idle or running, the MLX abort command will bring the system to servos off aborted. From here, there are two paths to bring the system back online. The first is to call MLX reset followed by an MLX enable. This will clear any motions in the queue. To preserve currently queued motions, you can call MLX reset and hold, MLX enable, and then MLX restart. Finally, while idle or running, you can use the MLX hold command to move the system to held state, and then the MLX restart command to move the system back to idle or running. Now let's talk a little more about how ladder code should be written to handle restarting cases. Most MLX applications use some concept of a program step. For example, if the step equals 10, some motions are performed, and when they are complete, it moves to step 20. And then on step 20, a configuration instruction is called, followed by a few more motions, and then the step is moved to 30 when they are complete, and so on. The user must also write the application logic that determines when this step variable is reset. So for example, you could reset the step anytime the system aborts, or anytime an MLX reset command is called. However, if you plan on restarting the system, the program should stay on the same rung as it was on when the abort or hold command was issued. So for example, if you reset the program step when the system entered servos off aborted state, you would not be able to properly do a reset and hold, enable, and restart sequence. One method that works in most cases is to use the servos off ready state to reset the program step. This state is only entered when issuing a MLX reset command, which will clear the motion queue anyways, and not through the two paths that involve restarting motions. The main takeaway here is that the states of the MLX instructions should not change during the time the system is held. One example where you might encounter a problem with this is again using the jump to subroutine command. Consider the ladder code we looked at before. Now let's consider the case where some external device had an error that triggers an MLX abort and also turns on the error signal bit. If this happens, the motion instructions inside the motion R0 subroutine will stop scanning, and you will not be able to do an MLX reset and hold, enable, and restart sequence. To prevent this, make sure that the runging conditions of the MLX instructions do not change when you want to restart the motion sequence. Another useful application scenario is to redirect a motion based on some input. This can be done with the MLX stop command, which will bring the robot to a stop and clear all motions from the queue. In the example shown here, we command a motion to a target position, and then if a sensor variable triggers, we call an MLX stop command and move the system to program step 100. Otherwise, the program moves to 20 when the motion is complete. In summary, it is important to understand the interaction between system state and the MLX instructions. And be careful how logic to reset the program step is implemented. A common solution to this that works in most cases is to reset the program step in the servos off ready state. And if using restart conditions, make sure that the runging conditions for the MLX instructions do not change from when the system stops to when it restarts. This concludes part 2 of the MLX Programming Guidelines and Common Mistakes tutorial. Thank you.